So in this problem, we need to show the derivative of y with respect to x is given by sine squared of a plus y divided by sine a whenever we have a implicit function. So let's begin with this particular implicit function. We have x times sine of a plus y plus sine a multiplied to cosine of a plus y. This is equals to 0. Now we'll transpose the second term to the right hand side to get x times sine of a plus y equals to negative sine a times cosine of a plus y. Now we're going to divide both sides with cosine of a plus y such that we have x times the one. Now in the left hand side we'll get the ratio sine over cosine, which is actually the tangent function. So we have tangent of a plus y, and this will be equals to negative sine a. Now we'll take the derivative on both sides with respect to x. So we have derivative with respect to x of x times tangent of a plus y, which will be equals to derivative with respect to x of negative sine a. Now we'll use the product rule for the left hand side. So we have derivative of x with respect to x times tangent of a plus y plus tangent we have x multiplied to derivative with respect to x of tangent of a plus y. Now a being a constant, so negative sine a will also be a constant, and its derivative will be simply 0. Right. The derivative of x with respect to x, that's 1. So we have tangent of a plus y plus x times. Now we have to take the derivative of the tangent function, which is secant squared. Now since we have a plus y, we have secant squared of a plus y, but we'll also have to use the chain rule and multiply it to derivative of a plus y. So this will be equals to 0. We can transpose tangent of a plus y to the right hand side. So we're left with x times secant squared of a plus y multiplied to, now derivative of a will be 0 plus derivative of y with respect to x. So this will be equals to negative of tangent of a plus y. Now what we'll do, we'll divide both sides with x times secant squared a plus y such that we have derivative of y with respect to x is equals to negative of tangent of a plus y whole divided by x times secant squared a plus y. Now what we'll have to do, we'll have to take care of this particular x here. If we go to this, let's label this as number 1, and we'll label this as number 2. So from number 2, what we can do, we can isolate x from here. So this is going to give us negative sine a divided by tangent of a plus y. So we'll substitute this value in place of x in this particular equation. Let's call it number 3. So that means we have negative times tangent of a plus y. Now in place of x, we will replace it with sine a divided by tangent of a plus y multiplied to secant squared a plus y. So this tangent of y will go to the numerator and will give us negative tangent squared of a plus y divided by sine a times secant squared of a plus y. Now the ratio tangent over secant, tangent theta over secant theta, that's equals to sine theta. Now since we have tangent squared a plus y divided by secant squared a plus y, we will have sine squared of a plus y whole divided by sine a. So this is the value of derivative of y with respect to x, and also this is what we were asked to show. Hence we have successfully proved the following problem.